Do you guys know what will be the current which will be flowing if it is a short circuit or open circuit? So this is the lecture for you guys. So let's take the concept of short circuit first. So what we mean by short circuit is that when two points are connected by a perfect conductor or a conductance with the zero resistance, then that is called as a short circuit. So here if you see this one, the red block here, it is with the zero resistance. So means R which is equal to 0. So what will be the current that will flow is that, so as R is equal to 0, we can clearly state V is equal to IR, that will also be equal to 0. So voltage across the thing is also equal to 0 because of R is equal to 0. So thing is that there will be no potential drop because both the end point are at the same potential. So zero potential difference between two such point. I can have any values based upon the rest of the circuit. So that is what the thing that we have to take into account. So even the current may vary, current may be anything, but the voltage across the thing that will be 0. So let's take the below example that here what will be the current flow is that. So when switch is equal to on and switch is off. So here switch is on and switch is off. So here the switch, when the switch is in on, that is considered as a short circuit. So let's take that one first. So if the switch is on, this will be a short circuit. If there is short circuit, then current will flow through this path. So this path will be cutted because the current will always choose the path that is with the low resistance. So the 4 ohms part will be cutted, means there will be no current flow, then we can remove that part. So if we consider only this part, then what will be the I flow is that I will be voltage divided by total resistance. So total resistance will be just 2. So the current flow will be 6. So if the switch is in off position, what will be the total current flow is that both the 2 ohms and the 4 ohms will come into picture because this will be open. So this will not be taken into account. So means what the current flow will be 12 divided by 6. So means the 2 ohms of current will flow. Okay. So this is how the open circuit and the connection part will make the difference over the circuit. I hope you guys are able to understand, right? So let's take the open circuit part. What do you mean by open circuit is that when 2 points in the network are not connected through any element, then that is called open circuit. So in the open circuit, generally current won't flow because of the current is not flowing. If I is equal to 0, then V or R which is equal to V divided by I. So if I is equal to 0, then R will become infinity. So there will be no current flow because of this. Okay. So if I is equal to 0, then that is an open circuit. The voltage can be anything. So voltage can be anything based upon the circuit, but the concept is that there will be no current flow. So if we take the same thing that we already discussed, if the switch is in off condition, we can call that as a open circuit. So if there is open circuit, what will be the voltage across the thing is that, then the current will flow is that 2 ohms of current will flow. So if 2 ohms of current is flowing, then the voltage will become 8. So if that is short circuited, then the voltage will be 0. So here the voltage, if it is a open circuited, current flow across that element will be 0. But if it is an open circuit, the voltage will be 8. So the thing that you need to take into account is that whenever the circuit is open, there can be voltage can be flowing, but current will be equal to 0. So think when it is shorted, voltage will be 0, but the current can flow. So that is what the quite difference that you have to take into account. So when a resistance is shorted, V is equal to 0, but current can be thing. So that is what the quite difference that you have to take into account. So let us also decline the few things, that is what you mean by power and energy in the resistance. So power and energy in the resistance, right? So P and E. So this is also very important in resistance. So let's take the instantaneous power, that is P of T, which is equal to I of T product of V of T. So this is the instantaneous power that we know. So from here, if we substitute R, so if let me take the case where V is equal to V of T, which is equal to I of T into R. So if we substitute the thing, then P of T, which is nothing but, if we substitute the thing, then that will be I square T R. Or if we substitute V, then that will be V square T divided by R. So this is how the power will come into picture. Series circuit, I is same. So in series circuit, I will be same. In series circuit, I which is equal to same. So if I is same, use this formula, that is I square R. Please remove the voltage. So if the circuit is in parallel, then the voltage will be same. So V will be same. Then we have to use V square by R. So these are two formulas we have to use based upon the circuit. So what will be the energy consumed is that E which is equal to area under the power graph. So area over P of T, integration of P of T over dt. So or even we can write as I square R dt, or even V square by R dt. Okay. So these are some different formulas to calculate power and energy. I hope this will be good for us to conclude our discussion over the resistance. So let us now discuss on the inductance. So inductor, so same thing. So inductor is nothing but a coil of wire. So let me take two analogies. So this is a straight wire. So in straight wire, whenever the current is flowing, there will be some magnetic field will be produced. How the magnetic field will be that? Like this way, the magnetic field will be produced over the current carrying wire. So this will be the weak magnetic field. So this will be weak magnetic field. Okay. So if the current is carrying over the say same, the current is carried over the wire, but the wire is twisted. So wire is twisted like this. So if the wire is twisted like this, then if the current is flowing over it, then the current or the magnetic field over it will be very strong. Okay, so the magnetic field will be very strong. That means strong magnetic field. So this is the general idea, guys. So if you guys got this point, then our discussion over the inductors will be very easy. So thing is that uh, Faraday's law is there. So I explained many of the things. So I hope many guys will be familiar with the Faraday's law. So let me also go over it. So Faraday's first law. Faraday's first law. So what the Faraday first law states is that whenever flux linkage through a coil varies with the time, an EMF is developed across ends of the coil. So thing is that whenever the flux linkage through a coil varies with the time, an EMF is induced. An EMF is developed. Okay, so this is what the first law. So what we can state is the flux linkage over the coil, which will be directly proportional to the integral of B over ds. Okay, this is a double integral. Okay, so B is the magnetic flux index. So magnetic flux will be directly proportional to the number of magnetic field lines crossing over the cross sectional area, guys. So flux linkage can also be linked with the flux linkage is equal to number of turns over the magnetic flux. So number of flux passing through the number of turns over the coil, that is also linked over here. So the flux linkage can also be directly proportional to the current I. So number of flux linkage will be directly proportional to the current I. So if we remove the constancy, then that will be Li. That the L is the inductance. This is what the self-inductance. So let me also clearly explain it. Then EMF induced, which will be directly proportional to the EMF induced, which will be directly proportional to d flux linkage to that of dt. So which can also be written as d di by dt, guys. So this is the end formula. So this is very important. Okay. So here thing is that so whenever the flux linkage through coil varies, there will be EMF induced. That means EMF will be developed across the ends. The magnetic flux that will be directly proportional to number of magnetic field lengths that is crossing over the cross section area. So taking into that account, we are taking that over here. So the part may be cylindrical area, anything. So we are taking the general definition, and also we having the another one formula that the flux linkage can be directly proportional to the current flow. So if we remove the constancy, then that will be Li, that will be self-inductance. So even it can be written as self-inductance because it is a single coil, right? So that's why the EMF induced can be written in the L di by dt. This formula is very important, guys, in case of inductance. So let's take the second law, Faraday's second law. What Faraday's second law states is that an induced EMF opposes the cause of induction. So that is an EMF induced, that will be the cause itself will affect the effect itself will affect the cause. I think you guys getting right. So because of the flux linkage, there will be induced EMF. That induced EMF produced will affect the flux linkage that is happening. So that is what we are making the negative sign here. So I hope you guys able to understand it. So let me write a general thing. So if the current is flowing over the flux linked coil, if it is flowing like this, if the current is flowing like this, then this will be a plus minus voltage. So this is L. So then V, which is V equal to L di by dt. Okay. So this is what the formula, guys. So because of this current flow, there will be some magnetic link fix happening. So because of the link fix, the induced EMF will be produced. The induced EMF will be directly proportional to the inductance to the di by dt. Okay. So this is how the cause of EMF, the change of current with the time. The EMF must oppose the cause. Okay. The inductance opposes the change of flux linkage, hence the current. Hence there is a change in current that is happening. Okay. So let's see the power and the energy calculation for this also. So as we see for the resistance, from that we can conclude this lecture there. So we know the V, which is equal to L di by dt. So this is the simple formula. If you guys haven't understand the Faraday first law, second law, just ignore it. So this one just formula will be very helpful for you guys. So let's take P of t. So P of t, which is equal to V of t to that of I of t. So if we apply this V of t here, then thing is the L I di by dt. Okay, so we are just applying the V of t. So means that is I of t. Let me write it as I of t so that you guys may not confuse. I of t into di by dt. Okay, so this is what the formula, guys. So energy stored. So U, which is energy stored, which is nothing but the area of pt over dt. Okay, so let me substitute the values. So U, which is equal to integral L I di by dt. So let me take that as simple I over dt. So dt will be get cancelled, and this will be area over the integral I di. Okay, so this is equal to half L I square. So because if we integrate I, this will be the formula. So energy stored over the inductance will be half L I square. So energy stored in an inductor at a time t, which is equal to half L into I. So if it is over the time, then we can write that as a U of t, which is equal to 1 by 2 L I of t whole square. Okay. So this is what, guys. So from here I think you guys able to understand the things. So if there is any dependence or any things, linear inductions or any kind of things is there, everything we can use the same formula. The inductor opposes the change of current. So that is what the main thing that you have to take into account here. So there is some law of flux conservation also. The flux linkage through an inductor cannot change instantaneously. So whenever there is a sudden change of instantaneous, that will not immediately happen. So that is also there. So that is not to be worried so much here. So that while solving the problem, we can take into discuss. So from here we have completed the resistor part and also inductor part. So stay tuned, guys. In next lecture we can discuss more on the same for the capacitance. I think if you guys have any doubt, please post in the comment section. What I can simply state is that whenever there is a current flowing over the inductance or the coiled wire or the circled wire, there will be flux linkage that is happening. Because of this flux linkage, there will be induced EMF produced. That induced EMF, which is equal to L di by dt. So that is for the thing. From there we are calculating the power, and then we are calculating the energy stored in the inductance. Okay. So next lecture we calculate the same for the capacitance. Stay tuned, guys. Like, share and subscribe channel. Thank you.